Guys, welcome back to the Off-Grid Garage here in super sunny hot Australia. The sun just came out actually. We had some rain last night, which is beautiful. And now we are back to 86 amps outside. In today's video, we want to have a look at the brand new JK-BMS. 5th generation. It is called JKESS. So far, I only had a very brief look at this BMS, hardware and specifications. Okay, let's have a look what's in the box. A bag full of cables, accessories, screws. And here it is. First look at the brand new JKESS BMS. So first thing you'll notice is we've got now 4 terminal connections to the BMS. Battery negative, positive, as well as load negative and positive. We've got nice thick aluminium plates at the top and at the bottom. A dedicated heatsink for the MOSFETs. Current limiter inductor. And then we've got connectors for cables, switches and accessories at the top and bottom of the BMS. 4-pin connector for a heating pad, a buzzer, a fan, RS485 and CAN, dry contacts, Wi-Fi and LCD. And on the other side we've got the balance connectors from B0 to B16, NTC connectors for the temperature probes and the switch. 2 M6 terminals for each of the connectors. So first impression, nice solid hardware. And yes, because we are doing size comparison here on the channel, you can see all 3 JK-BMSs here in one screen. This is the older style BD series of the JK-BMS, the inverter style BMS, the PB series here at the bottom, and the JKESS in the middle. And also the size of the new JKESS is somewhere between the BD and the PB BMS. 190 by 110. And 20 millimeters high. And so far with the BD and PB series of their BMSs, we only ever have the battery negative and the load negative connected to the BMS. Now with the JKESS, we also connect the positive of the battery and your load to this BMS. So using these new BMSs actually involves a bit more cabling effort, because you have to connect positive and negative of both battery and load to this BMS. While the previous models of JK-BMS only set in the negative path of your battery. So this is the balance cable connector, and we can see a nice labeling now from B0 all the way up to B8, and the same on the other side of the balance cables. Length of the balance cables 500 millimeters. Connection cable to link the BMS to the communication board. Buzzer cable. Another communication cable for RS485 and CAN. A fan connection cable. Connector for a heating pad. And I'm not sure what this cable is for. It says GPIO in and out. 4 temperature probes, 500 millimeters long. Power switch. Buzzer. Communication board with 3 RJ45 connectors and 8 dry contacts, and the usual terminal connectors as well. 8 M6 screws for the terminals. So, and this is how the BMS looks like when everything is connected. Got the balance cables down here, temperature sensors, the power switch, buzzer on this side, heating pads, fan connector, the communication board, GPIO in and out, connects to the dry contact. Not sure. I believe the BMS has a built-in relay, and that's what it is for. We will find out later. And I don't have any connectors for the Wi-Fi or LCD display, so this BMS didn't come with any display or something. It actually seems like it fits the old display. No, it doesn't. No, it's a different connector. Okay, and this concludes the first look at the new JKESS BMS. That's the hardware, that's what you get. And from the balance cables, obviously this is an 8S BMS, 4S to 8S. But they are actually soldering through holes here up to B16. So there will be a 16S version of this BMS as well. Plus, I'll show you in a second in the specifications. And unfortunately, neither the box nor the BMS has got a sticker or label what model it is. So I'm not sure if this is a 100 amp, 150, 200 amp BMS. I really don't know. And so far from all these connectors and accessories you can link to this BMS, there's nothing really special at the moment, except for the Wi-Fi connector here and the additional terminals for the battery positive and the load positive. Apart from that, makes a rock solid first impression. Cables are a bit short for my taste, but I also like the simplicity of this communication board now. Instead of having 5 RJ45 connectors, we have only 3. And it doesn't tell us on the PCB here which is RS485 or CAN, so I assume we can define this in the software. And another big difference with this combination is there are no dip switches anymore. This BMS does not use dip switches anymore. It uses an auto addressing system between master and slave. So with the JKESS BMS now, you can parallel unlimited amount of BMSs. It is not limited to 16 BMSs in parallel anymore. Okay, my friends, after having a look at the hardware, we want to now have a look at the specifications of this JKESS BMS. So this is a 16-page document, table of contents. So it looks like they've got a far better documentation now for these BMSs. So here's some general information about the MCU chip they are using and the state of charge, control and estimation. So I don't know if we get actually a lot of information out of this here. It says, for example, based on the in-depth study of the complex electromagnetic environment of the battery pack application environment, the EMC design of the product was fully considered at the initial stage of the design. So obviously EMC plays a role in this, because JK told me they want to use these BMSs also for electric vehicles in China. And a few of my viewers who are also radio operators, they have complained about the noise these BMSs are making. So obviously this has now been considered with this new JKESS BMS. So features and functionality, state of charge balance. So with this 5th generation of balance technology, they claim they can actually harvest 90 to 95% of the battery's overall capacity, and the voltage delta is under 10 millivolt. At this point, I'm not even sure when this SoC balance technology is kicking in. Is it a top balance? Is it balancing all the time? We don't know yet. Then here comes a lot of technical stuff about the MOSFET circuits they are using and the MP2793. I think a lot of what they are trying to explain here is getting lost in the translation. So I cannot really make any sense out of these details here. And they also publish here these detailed specifications for the MOSFETs they are using. 300 amps continuous current and up to 1100 amps of pulse current. If you want to read through all this yourself, please pause the video here. And then they go into further technical details about the accurate acquisition of voltage, current and temperature. They again mention this MP2793 chip and how it works with other chips together. So this is all very technical stuff. I don't really get any information out of that which are interesting. They are claiming they get a state of charge error here within 2%. And further down here, they're saying state of charge, state of health, and state of power estimate. State of charge accuracy is less than 3%, they are saying. When the BMS is in sleep mode, it uses less than 5 milliamps. And here comes something interesting. The BMS works with lithium ion phosphate, LTO batteries, and also sodium batteries. So obviously they've got a sodium battery profile now in this BMS here, which is very nice to see. Data is stored in the cloud for easy management. We don't have any further information about this. This is the first thing I'm reading here as well. I don't know what kind of data they are talking about, but obviously there is an option to connect this BMS to a JK cloud. What this exactly does, we don't know yet. When the BMS goes to sleep, it turns off completely except for the GPS function, and it wakes up automatically when there is a charge or discharge detected. Automatic addressing, we have no dip switches anymore, and it does all the parallel connections and communication automatically. As we have seen, we have got a built-in current limit module, supports unlimited parallel batteries now. These BMSs can also be connected in series now. For an 8S BMS, you can connect 2 of them in series. For a 4S, you can connect 4 of them in series. At this point of time, we don't have any information if we can series connect 16S BMSs as well to form a 96-volt battery system, as some of you wanted. So you can communicate with this BMS through a computer software, iOS, Android via Bluetooth, Wi-Fi connection, and it also has a GPS functionality as well. The BMS can be upgraded via computer software as well as from the app now. That's a really good feature. Yeah, and JK talked about the alarm levels as well in this new BMS here. Apparently we've got now 3 different alarm levels we can set. We've got level 1 alarm, only the buzzer prompts you if you exceed the set value of alarm number 1. Level 2 is the buzzer goes on as well as the BMS goes into a protection mode when one of these set levels is exceeded. And then when this value recovers, the BMS actually starts working again. And there's now a level 3 alarm as well. Buzzer, BMS disconnects, but in this case it does not reconnect anymore. You have to manually go to the BMS and restart it. And we also have some kind of gyroscope integrated in this BMS. It says it's often used in base stations communication or places requiring high stability. So whenever you get some vibrations or movement or something, the BMS alarms or turns off or disconnects or whatever. So there's this feature as well, but it is optional. Heating function, up to 200 watts, 5 amps. Fan output, 12 volt, 40 milliamp. Good luck finding one. Dry contact, 12 volt, 40 milliamp. They probably refer to this single dry contact here with the bare wires coming out of the BMS, and not to the dry contacts here on the communication board, because 40 milliamp is a very small current. Then we've got the usual BMS protection functions. There's a V missing. Overcharge protection, over discharge protection, overload, over temperature, shortcut, over current, electrostatic protection, and a drop line detection. So, and now it gets really interesting. Here is a schematic diagram of the new JKESS BMS. So obviously we've got the MCU here in the middle, which has all the connections to UART, Bluetooth, GPO, CAN, RS485, TTL fan, and so on. There's a state of charge balance module on the left, monitoring and controlling all the battery cells. We've got the battery connected with B positive and B negative on the left. And we've got our load or charger connected P positive and P negative here on the right. And what you can immediately see here is that the MOSFETs are actually working in the positive line of the BMS. Between battery positive and your load or charger positive, here are the MOSFETs. Yeah, there are no MOSFETs down here, it's just a diverter, but no MOSFETs in the negative line of this BMS anymore. We are going back to switching positive lines. Yeah, why not? And up here is also the current limiting parallel module. This is bypassing the MOSFETs. If the BMS turns off because of an overcurrent situation, for example, the current limiter, if activated, kicks in and limits the current between your charger and the battery to 10 amps only. So further down here, they've got a table with all the models for their chips and what they are doing. The dimensions of the BMS, picture of the BMS with all the connectors. And here's the table stating all the pin outs for this BMS for every single connector. We've got the communication or interface board sizes here, 3 RJ45 connectors. Further down here, a picture of the front and back of this PCB. And here's also the pin out of this communication board. So for each of the 3 RJ45 connectors, 1, 2, and 3 here, we've got RS45A and B, and we also have a CAN high and low. So as I said before, I actually assume we can define what these RJ45 ports are being used for. Either internal communication, communication to a computer, or CAN communication to your inverter. So, and interestingly, the JC5, this is our dry contact connector here, the JC5, 8 pins, and only 2 of them are actually dry contacts. 2 of them are not even connected, and another pair is for the TTL communication apparently. So looking at this, it seems like we have lost a bit of functionality in comparison to the old inverter style BMS, where we had 2 full dry contacts which we could program in the application, in the mobile app, for overvoltage, overcurrent, or any alarms or something. What's in the box? The BMS itself, the balance cables, the temperature sensors, and the switch. Everything else is optional. So the buzzer is optional, not sure what this switch is for here. TTL cable, Wi-Fi cable, dry contact cable, all the other cables, fan cables, buzzer cables, everything is optional, as well as the interface board. So this BMS does not come with the interface board by itself. It's an optional feature. Installation is a bit different to all the other BMSs we had before, because we connect this BMS to battery negative, battery positive first, and then connect the balance cables. And then you obviously connect your load and your chargers on the other side of the BMS. So you can see this here in this diagram. Battery is on one side, all your load and chargers is on the other side, and then you've got all your connections to the balancer, communication boards, and all the other accessories you want to connect to this BMS. So there are some general specifications here, monomer or single voltage detection between 0 and 5 volts. It measures the cell voltage with an error of 5 millivolt. Total pressure detection, current detection, negative to positive 300 amps, charging and discharging, error smaller than 1%. Short circuit protection, overcharge, discharge, fault record, working power consumption, we don't know. Standby power, they mentioned something about 5 milliamps. Working temperature, negative 40 to plus 85 degrees Celsius. Built-in Bluetooth, supports Android and iOS. Number of detected strings, 4S to 8S at the moment. Lithium iron phosphate, LTO, and sodium batteries. Equalization function is the state of charge balance. State of charge estimated accuracy is with an error of lower than 3%. CAN communication to your inverter, but two-way RS485 communication between your computer and also parallel boards. Temperature detection supports PC, Bluetooth, fan, start, close conditions, and so on. All right, I think we are almost through. And in the last page, they also have an overview what kind of BMSs they are going to make. So it seems like these BMSs are called BDC BMSs, so it's the BDC series. We've got the BD, which is the old style, we've got the PB inverter style, and now the BDC series, which is this JKESS BMS. 4S to 8S, which is this one here, and they also have sodium batteries 4S to 8S now in the program. Then I've got 8S to 16S, 17S to 24S, and also 25S to 32S. And further down here you can also see a 25S to 36S. So you can actually build your higher voltage battery now. But these three BMSs here, they have a relay, so they don't have MOSFETs anymore. They are probably for high current applications then. But for all other sort of BMSs here, we also now have a 300 amp BMS version. So it starts from 50 amps all the way up to 300 amps. All of these BMSs have the new state of charge balance technology and the accuracy as mentioned here in the table. So this is the same for all these BMSs here. Yeah, and this basically concludes this 16-page document. So guys, what are we missing now here? We don't have any information about the balance current, right? It only says it does this SOC, this SOC balance. But what does it actually mean? So, and JK tried to explain this to me. I'm not sure if I have understood this correctly, but basically state of charge balancing function means that they are creating a virtual voltage which charges your low voltage cell. Yeah, so far we had all the cells in series and the BMS measured each of the single battery or cell voltages. And then energy from cells with a higher voltage gets somehow transferred into cells with a lower voltage. Yeah, one cell has 3.5 volts, the other cell has only 3.4 volts. We've got a difference of 100 millivolt, and this is what drives your current into this battery. But now they are using each of the single individual cell voltages to create a higher virtual pack voltage, and using this overall voltage to charge this low voltage cell. And this obviously is a far more efficient way to do that. And JK claims that actually the inductive balance method has actually an efficiency of around 25% only, and 75% of the transferred energy gets lost. Then the capacitive balancers we all like so much have an overall efficiency of around 45%, they are claiming. So over half of the energy lost. So then they developed this unidirectional balance function, and this already uses the virtual total voltage of the battery to charge a single cell. Efficiency they have achieved with that is 75%. And now this new JKESS BMS here has the SOC balance function, which is a combination of all the above. It uses bidirectional balancing, and what they are saying is basically state of charge equalization. Logic is based on bidirectional DC equalization and pre-equalization with reference to state of charge OCV curve. So obviously they're looking into more of the cell parameters now, and including the curves for charging and state of charge as well. So it says here, during the charge and discharge of the whole battery pack, the state of charge value is estimated, and then the SOC and OCV curve is referred. And it also says the whole battery pack is pre-balanced in advance, which has nothing to do with the overall consistency of the cell. Within the state of charge balance range, the capacity of the battery pack can always be kept within 5% of the capacity of a single battery until the battery pack capacity is less than 80% in the 13th year. This test can increase the battery life by 30%. So this is the information, the explanation they have sent me, and I think there's a lot of information, explanation missing or being lost in the translation. So I don't know exactly how this all works out, but they're claiming they can actually prolong the battery life now because of an optimized balance function with your cells. And apparently this is all built into this JKESS BMS now. So I don't know, this sounds to me like a very different balance method now, and I'm not sure if we can actually measure any balance current now. We don't know how large the balance current is, or is there a balance start voltage? Does it do this pre-balance in advance situation at some stage? I don't have any information. I don't quite understand how this all works. This is only what they gave me, and well, I read it multiple times and tried to make sense out of it, did some research as well on it, but you can't actually find anything on it. And they also said this is actually designed for electric vehicles to prolong the battery life in these cars. And apparently this is the latest and greatest and best and most efficient balance method at the moment on the market, with over 90% efficiency. So there you have it, the brand new JKESS BMS hardware, all the cables and accessories connected. And we also had a detailed look at the specifications and features of this BMS now. So this is basically all I have for you at the moment here. I'm not sure how this all works. It all sounds very theoretical and magically. It seems like it goes into an area where I don't understand how the BMS works anymore. So this is far beyond any passive or active balancing function. They're claiming it's a high efficient balance method and it will prolong your battery life by up to 30%. And if they really do some pre-balancing before the actual battery is fully charged or something, it would be pretty difficult to actually see this because we don't have any defined starting point for the balancing anymore. But we will see this in the next video when we actually connect this BMS to the battery and have a look at the computer software as well as the app, and hopefully can do a first charge and discharge of the battery and see how this new JKESS BMS actually works and behaves. So guys, this is a lot of information, a lot of theoretical information as well. Leave your comments down below what you think about this BMS. I really, at the moment, I'm holding back with my own opinion. I really want to hear what you think about this BMS and the features and function and specifications first. And I actually had this, hang on, just want to show you something here. Before they actually sent this BMS to me, I had a poll on my YouTube channel in the community section. I want to quickly show you. Ah, here it is. Hang on. I'll turn on the screen recorder. All right, there you go. So I was asking, what would you like JK to prioritize their work on? 1. Fixing issues with the version 14 inverter BMS. 9% only have requested that. Fixing issues with the version 15 inverter BMS. 53% of the people have actually requested that. Or developing a brand new, more efficient BMS with better state of charge calculation. 38% of you, that was like 1,000 people have replied to this poll, and 38% of them didn't give a crap about the version 14 or 15. They just wanted this brand new BMS now. Well, here it is. Almost. So, as I said, I'm very keen to read your comments about this new JKESS BMS now with this state of charge balance, pre-balance functionality, what I just tried to explain to you. I don't know, it's very hard to understand for me what they are actually doing, how they are doing it, how this all works with the virtual voltage. Yeah, it makes it all a bit hard to understand, I think. 98,170, where is it? Here, 5 subscribers. Thank you so much, guys. We are less than 2,000 subscribers away from the 100,000. That is crazy. As always, guys, thank you so much for watching. Thanks for all your amazing support. Welcome to all the new subscribers here. Thank you to everyone who has donated to the channel or becoming a channel member, supporting me on a regular basis here. Thank you very much. Thank you very much for all your comments and likes and sharing these videos in forums. As you know, this all makes these videos possible. They wouldn't be here, I wouldn't be in the garage, I wouldn't wear this nice t-shirt here, and we wouldn't be talking about the JKESS BMS. Yeah, let me know what you think. Alright guys, until the next video when we actually connect this BMS here to a battery and have a look at the PC app as well as the mobile app. Have a bit of a play with it and see what we actually can do. Until then guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye.